Today we are going to discuss about the Mohr circle diagram method. In the last class we discussed the planar stress transformation equations. This Mohr circle diagram method is a representation, okay, graphical representation of these stress transformation equations. Okay, graphical representation of this stress transformation equation. That means we can graphically represent how stresses are vary on a inclined plane. Okay. Actually this graphical representation having it represent stresses on a point on a circle. It having the two axes, normal stress axis and the shear stress axis. Okay, the each point on a circle represent certain plane, stresses acting on a certain plane. Okay, this is very easy method to read stress on a two-dimensional problem. If we are having the Mohr circle diagram, then we can directly read the stresses acting on any inclined plane. That is very useful when finding the stresses on a two-dimensional stress problem. Okay, let's see about the theory of this today's class. Let's move to the theory. Okay, today's topic is about the Mohr circle diagram method. Okay, the Mohr circle diagram method is a graphical method to represent the two-dimensional stress transformation equations. Okay, in the last lecture we discussed about these stress transformation equations. So what are the stress transformation equations? Let's take this kind of two-dimensional stress system, sigma x, sigma y, sigma y, tau xy, okay. Let's take this kind of a two-dimensional stress problem. In any inclined plane, let's take a certain inclined plane. This is stress. This is the inclined plane we are considering. Let's take it is make theta angle with the positive x coordinate axis. This is the positive x coordinate axis. It produces theta inclination. That means it's normal producing the theta inclination with the positive x coordinate direction. Okay. Then when marking the stresses on this kind of inclined plane, we have a sign convention also. In this direction, we have taken the sigma theta as positive. That means if this shearing normal stress acting outward from the stress element, considering stress element, we are taken as positive. Then shearing stress, if the acting shearing stress tends to rotate the considering stress element in anticlockwise direction, we are taken as positive. This is how we are marking the this is the sign convention when marking the stresses on inclined plane. Okay. Then we have two equations also to find these sigma theta and tau theta, called stress transformation equations. Okay. The first one, sigma theta is equal sigma x cos square theta plus sigma y sin square theta plus 2 tau xy sin theta cos theta. Then for the tau theta we have in the equation, tau theta is equal minus sigma x minus sigma y divided by 2 sin 2 theta plus tau xy cos 2 theta. Okay, These are the two equations. These are the two equations we can use to find the sigma theta and tau theta. Okay. Then last class we obtained these two equations considering the force balance. Consider the force balance of this triangular shape stress element. Okay. Last class we obtained these two equations. Then this first equation, let's take this is A. This equation I am going to write using the 2 theta angles. Okay, from A I am going to write it using the 2 theta angles. So what is the 2 theta angles? I think you all know these equations. Because 2 theta is equal to cos square theta minus 1. Then the cos 2 theta also we can write using 1 minus 2 sin square theta. Then the sin 2 theta is equal to sin theta cos theta. Using these three equations, I am going to convert this equation A to a 2 theta angles. 2 theta angles. What we are going to do is we are going to obtain the Mohr circle diagram. That means we are going to represent these two equations on a graphical format. Okay. Then before going to represent in a graphical format, we have to convert into a 2 theta angles. So then sigma theta is equal sigma x cos square 2 theta cos 2 theta minus 1 divided by 2 plus sigma y sin square 2 theta 1 minus cos 2 theta divided by 2. So I'm going to directly write this at 2 sin theta cos theta plus tau xy using this equation sin 2 theta. Okay. Then we can further simplify this equation. Sigma theta is equal, here sigma x divided by 2, sigma y divided by 2. I am going to add these two. Sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta plus tau xy sin 2 theta. Okay, we can write in this format. Okay, so I am putting this one as let's take this is equation 1. Then I am going to take this equation as equation 2, that is in already in 2 theta angles. Okay, 2 theta angles. Then let's take these two equations. Let's take these two equations. In these two equations, from equation 1, from equation 1 I'm going to make this one to subject sigma theta minus sigma x plus sigma y divided by 2. I'm going to take this term into left hand side is equal sigma x minus sigma y divided by 2 cos 2 theta plus tau xy sin 2 theta. Let's take this equation as equation 3. Okay, equation 3. Then I will write the shear stress equation in here also. What is the equation for the shear stress? Tau theta is equal minus sigma x minus sigma y divided by 2 sin 2 theta plus tau xy cos 2 theta equation. We have given the number 2. Okay. Then in these two equations, I am going to take square of 3 equation. Square of 3 equation plus the square of second equation. Okay. 3 into square plus 2 into square. So I am going to take the square of this part and I am going to add to the square of this part. Okay. I will write the equation. Okay. I will write that equation. Sigma theta minus sigma x plus sigma y divided by 2 into square, okay, plus tau theta square is equal I'm going to take the square of this term, sigma x minus sigma y divided by 2 cos 2 theta plus tau xy sin 2 theta into square plus minus the square of this term, sigma x minus sigma y divided by 2 sin 2 theta plus tau xy cos 2 theta into square, okay, into square. Okay. Then we can further simplify this one. Okay. Sigma theta minus sigma x plus sigma y divided by 2 square plus, for the tau theta I am going to write this format. It's more, there's no variation because sigma theta minus 0, no problem. Okay. Then taking the square of this one, you can see I'll write that one also. Sigma x minus sigma y divided by 2 into square cos square 2 theta plus tau xy into square sin square 2 theta plus 2 of these two, multiplication of these two terms, 2 into multiplication of these two terms, sigma x minus sigma y divided by 2 cos 2 theta tau xy sin 2 theta, okay, plus this term, expansion of this term, sigma x minus sigma y divided by 2. I'm not going to write the square because when squaring it become positive, sin square 2 theta plus tau xy square cos square 2 theta, then the multiplication of these two terms minus, because here it is minus sign, sigma x minus sigma y divided by 2 sin 2 theta into tau xy cos 2 theta. Okay. Then this expression we can further simplify. Okay. This expression I am going to simplify further. Okay. Here this one we can write sigma theta minus sigma, I am going to write, you can see sigma x plus sigma y divided by 2. That means I am going to write it as a sigma average. No problem. Sigma x divided by sigma y divided by 2, I am going to write as a sigma average. Okay. Plus tau theta minus 0 into square is equal. Here you can see we can cut this term here, the minus and the plus sign, we can cut these two terms. So then remaining only remaining one also we can write in this format: sigma x minus sigma y divided by 2 into square here cos square 2 theta plus sin square 2 theta, okay, plus tau xy square sin square 2 theta plus cos square 2 theta, okay, cos square 2 theta. Okay. Then what is this equation? You will know this term is equal to 1. You will know this term is equal to 1. This is equal to 1. This one also equal to 1. Okay. So then this equation we can further simplify in this way: sigma theta minus sigma average into square plus tau theta minus 0 into square is equal, only remaining one is sigma x minus sigma y divided by 2 into square plus tau xy into square. Okay. Then this term I am going to write in this format. I am going to take the square, then I am going to take the square. Okay. Doesn't any change. Then what is this equation actually? Okay. What is this equation? Okay. If sigma theta and tau theta are variable, then all other are constant. Only these two variables, sigma theta and tau theta. What is this equation? I think you all know this equation. Okay. Then what is this equation? X minus a into square plus y minus b into square is equal r square. What is this equation? This is the equation of a circle. No, this is the equation of a circle. That means circle having AB center, A, B, and the radius R. Okay. X. This equation representing this kind of circle. Same way, this equation also representing the circle. So what is that circle? This is the x coordinate of the center here. This is the center. What is the center of the circle for this one? Center sigma average, 0. That means always the center lie on the x-axis. Always in a Mohr circle diagram, center lie on the x-axis. Okay, remember that one. Then always center at the average stress value from the coordinate 0. Okay, that is the property of the Mohr circle diagram. So I will show that graphical represent this one. I am going to represent this one in graphically. According to the obtained equation, you can see it should be in somewhere in sigma average. Okay, then the center lie on the if this is a sigma theta axis, if this is a tau theta axis, it should be lie on this sigma theta axis. Then this is the circle. With the circle we obtain. With the circle we obtain. Okay. Then this radius, let's take it as r. That r is equal sigma x minus sigma y divided by 2 into square plus tau xy into square root. Okay, this diagram is called Mohr circle diagram. This is how we obtain the Mohr circle diagram in mathematically. Okay. I think you all clear with this obtaining this Mohr circle diagram, no? So what is the property? The center always lie on the sigma theta axis, and its center coordinate are sigma average comma 0, and also its radius always is equal to this value. Okay, these two properties we know. Okay. Okay, I will draw a very clear diagram what we found. We found sigma theta minus sigma average, sigma theta minus sigma average into square plus tau theta minus 0 into square is equal sigma x minus sigma y divided by 2 into square plus tau xy into square root into square. This is the equation we got finally. It is a equation of a circle. It is a equation of a circle. So we can draw this circle. We can draw this circle. We can draw this circle in this way. The two axes, sigma theta axis, tau theta. That means this equation representing how tau theta is vary against the sigma theta. Okay, tau theta is a variation of tau theta against the sigma theta. It's actually a circle. Okay, actually it's that variation is a circle. Okay, I'll draw this diagram in this way. Okay. Okay, this is the sigma average. This is the sigma average. Then this axis is sigma tau theta. Then this is the plot we got for this equation. That means this is how the plane stresses vary in different orientations. Okay, for when varying the theta, this is how sigma theta and tau theta vary. Each and every point on this circle representing certain stresses, normal stress and the shear stress acting on a certain inclined plane. Okay, each and every point representing. Okay, then when representing, for example, let's take, okay, when we are going to represent these stresses, we should have a sign convention. Okay, later I will explain this sign convention and everything. For example, let's take if you take tau theta, we are measuring in a clockwise manner, let's assume. Okay, for example, let's this kind of point, let's take this kind of plane stress system for a certain point, sigma x. Okay, this is tau xy, here sigma y, sigma x, tau xy like this. Okay, sigma y. Okay, then in here let's take this plane, the plane which is normal to the positive x coordinate direction. Let's take it as a. Okay, you can see the tau xy, sigma x, the according to sign convention the tau xy is negative, so we have to mark. Let's see how to mark this a point. Let's see how to represent a point shearing stress and the normal stress on this Mohr circle. Okay, then let's take the a point coordinate. What are the a point coordinate? Here sigma theta coordinate, sigma x comma tau xy. According to our sign convention we assign, it is negative tau xy. Okay. Then that point we can represent on this diagram in like this: sigma x somewhere in here. Okay, then tau xy is negative. Okay, maybe somewhere in this kind of point is representing the a point. Okay, this is a, this is sigma x, then this is minus tau xy point. Okay, either you can see this a point is representing these two stresses. By reading this a point we can find the stresses acting on that point. Okay, then in this diagram you can see another important property. At this point sigma theta is maximized. This is the point where sigma theta is maximized. This is called maximum principal stress. This is at this point sigma theta is maximized. Okay, then you can see another point, the sigma theta is minimum, sigma minimum value. Okay, sigma minimum value. This is sigma maximum, sigma minimum, and also here you can see it is sigma maximum, tau maximum value, tau maximum. Then here it is tau minimum value. You can see the magnitudes are same, but only the direction is changed. Okay, tau maximum. Okay, tau maximum. Another important thing you can notice, you can see at the maximum at the principal stresses, that means the maximum or minimum stresses, shearing stress is equal to 0. Okay, that means on this plane the shearing stress acting on that plane is equal to 0, because you can see the tau value is equal to 0. What is the coordinate of this point? If you take the coordinate sigma maximum comma 0, that means shearing stress is equal to 0. So another important property we notice, at the maximum shearing stress principal stress planes, shearing stress is equal to 0. Okay, here we how mathematically obtain this equation for the Mohr circle diagram. Okay, Mohr circle diagram. Okay, then I am going to explain what is the sign convention used in when drawing the Mohr circle diagram. Okay, sign convention. Sign convention used for when drawing the Mohr circle diagram. Okay, let's see. Okay, let's see the sign convention. Sign convention when drawing the Mohr circle diagram. Okay, when drawing the Mohr circle diagram, we have to follow the sign convention. So what is the sign convention? When drawing the Mohr circle diagram, okay, let's take the plane stress problem. Okay, when marking the stresses on a two-dimensional stress element, what is the sign convention? The outward stresses we are taken as positive. If the stress is acting outward from the considering plane, we are taken as positive. Okay, then when marking the shearing stresses, what is the sign convention we use? if shearing stress acting on a positive plane and it is directed to positive coordinate direction, we are taken as positive. Okay, according to that, this tau xi is positive. Then here this is the positive way of marking shearing stresses. If any shearing stress acting on a negative plane and it is directed to negative coordinate direction, we are taken as positive. This is how we are marking stresses on a two-dimensional stress element. When drawing the Mohr circle diagram, that is very important. We have to adhere to one of the sign convention. Sigma theta as same. Sigma theta as same. That means if any stress acting outward from the considering plane, we are taken as positive. Okay, it's no problem. But when drawing the Mohr circle diagram, we have to, when taking the shearing stress, we have to consider one direction. We have to consider one direction shearing stress as positive. Okay. In most of the situation, the clockwise shearing stress we are taken as positive. In most of the books taken this clockwise shearing stress positive. If you take the anti-clockwise, in some books also using the anti-clockwise shearing stress taken as positive, that one also correct, no problem. This sign convention also correct, no problem. But in most of the cases, most of the books, most of the countries using this sign convention, but what it means, the clockwise shearing stress we are taken as positive. Okay, as a bit anyhow, if you take other way around, that one also give the Mohr circle diagram, but that means that it's a polarity only change. But you have to adhere one sign convention. As a good practice, I am suggesting to put what is the sign convention used to draw the Mohr circle diagram by using this kind of symbol. Okay, as a good practice, put this symbol to show in which direction we use positive shearing stresses. Okay. Then another important thing is, when angle measuring for this two-dimensional diagram, for example, let's take this kind of inclined plane we are considering. Okay, when considering this inclined plane, the anti-clockwise direction we are measuring the angles. Okay, we are measuring anti-clockwise from the positive x coordinate direction for the angle. Okay, but in when going to the Mohr circle diagram, if we take clockwise shearing stress as positive, in that situation we are measuring angle anti-clockwise direction. Okay, remember that one. If we take clockwise shearing stress as positive, we can measure angle on same direction. Okay, if we take anti-clockwise shearing stress as positive, we have to measure angle other way around. Okay, so one of the reason we take this clockwise shearing stress as positive, why? To make this angle measuring direction same with the Mohr circle diagram and also the two-dimensional planar diagram. Then we can easily calculate. There's no confusion with the angle measuring direction. This is one of the reason we take this clockwise shearing stress as positive. Another important thing is, when measuring for the two-dimensional planar stress diagram, if we take certain angle as theta, but in a Mohr circle diagram it is representing double 2 theta angle. If we take a certain angle as theta, it is represented on a Mohr circle diagram double value. Okay, double value. Okay, for example, let's take this is a certain A point. Okay, let's take this kind of A point. Okay, then okay, before going to say this one, to represent other plane, we are representing other plane on this Mohr circle diagram a reference to certain fixed point. Okay, we are representing other planes reference to certain fixed point. So in most of the cases we are using these planes as fixed points. These planes as fixed points. Okay, if you mark this A point on this Mohr circle diagram, we have these two values, sigma x and tau xy values we have. Then we can easily mark this A point. With reference to the A point, we are marking the stresses on other planes. Okay, in that way we need this theta value. Okay, for example, we have taken this plane as a reference point. Okay, then we are measuring anti-clockwise from the positive x coordinate direction. If you got the theta value here, this is the plane which is oriented normal to the positive x coordinate direction. This is the reference plane we are reference point we are considering. Okay, reference point we are considering. We are measuring this angle from this point. That means if we take positive clockwise shearing stress as positive, we have to measure anti-clockwise angle, same with this diagram. Okay, then but angle is double. That means if we take a theta, this one should be 2 theta. This one should be 2 theta. This is 2 theta angle. Now this kind of plane is representing this stress on. That means C point is represented by this kind of point on the Mohr circle diagram. Okay, then if you know this 2 theta, we can locate the C point. If we know this 2 theta, we can easily locate the C point. Then we can find the sigma theta and tau theta by reading these values. We can find. Okay, that is the thing we are doing. This is how we are finding the unknown point stresses. First, we have to locate this A point. Then from the A point, we are measuring these angles. Then we can locate the unknown point on the circle. Then by reading these two values, we can find the sigma theta and tau theta for that point. Okay, that is the thing we are following. Okay, then this is the sign convention. The why if we take the clockwise shearing stress as positive, why we have to measure angle anti-clockwise in Mohr circle diagram. Why? Okay, why if we take angle is theta, then why it is represented on 2 theta angle in Mohr circle diagram? We have two questions. Okay, we have two questions. Okay, so this is the sign convention. If we take clockwise shearing as positive, we have to measure angle anti-clockwise. Okay, then if we take a theta angle in a planar diagram, we have to represent on a 2 theta angle on a Mohr circle diagram. Why? Okay, then next I am going to explain why this is happened. Then we are going to obtain this sign convention mathematically. Okay, we are going to obtain this sign convention mathematically. Okay, let's see. Sign convention explanation. Okay, then let's see the sign convention explanation. So I am going to explain why we are using this sign convention. Okay, then let's take this kind of a two-dimensional stress problem. Okay, sigma x, sigma y, here sigma x, sigma y, here the tau xy. Okay, tau xy. Okay, then let's take another inclined plane also. Here our coordinate direction x and the y. Let's take the inclined plane, theta angle. Then let's take this is the normal to the considering plane. This is the x coordinate direction. This angle is viewed as theta. Then this is sigma theta. Then this is tau theta. Okay, then let's consider the let's consider the Mohr circle diagram for this situation. Okay, let's consider the Mohr circle diagram for this situation. Sigma theta, here the tau theta. Okay, then let's draw the Mohr circle diagram. Okay, then these stresses we are going to represent by this kind of Mohr circle diagram. Okay, let's assume we can represent stresses on this kind of Mohr circle diagram. Okay, then okay, this is the Mohr circle diagram for this situation. Okay, then let's assume our sign convention. We are going to explain this sign convention. Let's assume sign convention we took is as the tau theta in anti-clockwise direction we are taken as positive. Okay, positive. So according to sign convention, we are going to mark these stresses. Let's take the A plane which is normal to the positive x coordinate direction. We are taken as A. For the A plane coordinate, we can mark in this way: sigma x, comma tau xy. Both are positive according to our sign convention. Okay, both are positive according to our sign convention. So then that point we can mark in this way, somewhere this kind of point, because both are positive. Somewhere in this kind of point. Here it is sigma x. Here it is tau xy. Okay, tau xy. Then let's take, this is the point, the C, this kind of point. Then the C point we are going to mark. We don't know how to mark this C point. Let's take from the A point, let's assume it is away from the alpha angle. Okay, let's assume the C point is away from the, at an angle alpha from the A point. That means let's assume the C is in this kind of position. This angle is alpha. Alpha is an unknown value. This angle is alpha. This alpha is unknown value. Then we are going to obtain the expression for the alpha. Okay. Then we are going to obtain expression for the alpha. We are going to find alpha from the known values. If we know the alpha, we can exactly locate the C point with reference to A point. That is the thing we are going to do. Okay. If our sign convention is if alpha is got negative value, it may be in other way around. If alpha we got the positive value, we are measuring anti-clockwise direction. Okay, let's see what is the value we are getting for the alpha. Okay, then in that way we can define the sign convention. Okay, for the planar stress problem, what is the equation for the sigma theta? What is the equation for the sigma theta for the planar stress problem? If you take this is the, what is the equation we got for the sigma theta? We have got this equation: sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 into cos 2 theta plus tau xy sin 2 theta. This is the equation for the sigma theta we obtained from the planar stress equations, stress transformation equations. Okay. from this Mohr circle diagram, what is this value for the C point? From this Mohr circle diagram, if we consider the Mohr circle diagram, what is the, how we can find this value, sigma theta value? This sigma theta is represented by the stress, no? See the point, the sigma theta, no? Sigma theta for this C point, no? Sigma theta. So what is this value? This is sigma average, no? Sigma average. Here it is R. Okay, you can write in this way the sigma theta value from the Mohr circle diagram. From, I will write this one as the from equations. Here the from Mohr circle diagram. Mohr circle, from Mohr circle sigma theta is equal, how to write it, how to write that value? Sigma theta value is equal sigma average plus here R cos. Okay, then I'm going to put this angle as angle beta. Okay, R cos alpha plus beta. Okay, this angle I am taking as beta. Okay. R cos alpha plus beta. Okay, from the equation we got this value. From the Mohr circle diagram we got this value. Okay, no confusion. Okay, then these two should be equal because it is same one plane. These two should equal. Okay, these two should equal. Then I'm going to equal this A and B. Okay, A and B should equal. So I will write that one also. Then sigma x. Okay, sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 cos 2 theta plus tau xy sin 2 theta should be equal to sigma average. What is sigma average? Sigma x plus sigma y divided by 2, sigma average. Okay, plus R cos alpha plus beta. Okay, here the equation we got. In this equation, this is the common term we can cut in this way. Okay, common term we can cut. Then finally we are remaining this value. Okay, finally we are remaining this one, sigma x minus sigma y divided by 2 cos 2 theta plus tau xy sin 2 theta is equal R cos alpha plus beta. Okay, alpha plus beta. Okay, then here what is R? Here what is R? Here what is R? When obtaining the Mohr circle equation, what is R? Okay, this is the R, no? This is the R. This is R. I will write that one. Sigma x minus sigma y divided by 2 into square plus tau xy into square root. This is R. Then I am going to divide this entire equation by R. I am going to divide this entire equation by R. Okay. I am going to divide this entire equation by R. Then we are getting this value. We divide this entire equation by R. We are getting this value. Okay. Okay. Then sigma x minus sigma y divided by 2 divided by sigma x minus sigma y divided by 2 into square plus tau xy into square cos 2 theta plus tau xy divided by sigma x minus sigma y divided by 2 into square plus tau xy into square root. Okay, sin 2 theta is equal cos alpha plus beta. Okay, cos alpha plus beta. Then for this term I am going to write this one. If we take this kind of triangle, we can represent this angle. If we take the let's take this one as the gamma. If this is sigma x minus sigma y divided by 2, then this is tau xy. Cos gamma we can write using this term. That means this r is equal for this side. This is a right angle triangle. Sigma x minus sigma y divided by 2 into square plus tau xy into square root. Then cos gamma is equal to this term. Sin gamma is equal to tau xy divided by sin gamma is equal to this term. Okay. Then this equation we can reduce in this way. Cos gamma into cos 2 theta plus sin gamma into sin 2 theta is equal cos alpha plus beta. Okay. Cos alpha plus beta. Okay. Then we can add these two angles. How to add these two angles? What is the cos gamma minus 2 theta, no? Cos a minus b is equal cos a cos b plus sin a sin b. Like that, cos gamma minus 2 theta is equal cos alpha plus beta. In that way we can write. Okay. No problem. Okay. Then what is gamma minus 2 theta? Gamma minus 2 theta that is equal to for the first quadrant angle, sorry, in a general solution, the cos 2 and 5 plus or minus alpha. So I am taking the plus or minus alpha plus beta. Okay, the plus or minus alpha plus beta. Okay, in this equation I am going to make alpha into here we have the two values. So what are the two values? What are the two values we are getting? Okay, gamma minus 2 theta plus alpha plus beta. So this is gamma minus 2 theta is equal minus alpha minus beta. Okay, by making the alpha into subject in this equation, we are getting alpha is equal minus beta minus gamma minus 2 theta. Okay, in this equation we are getting alpha is equal 2 theta minus beta minus gamma. Okay. Okay, then let's move to this diagram. In this diagram you can see what is sin beta. Sin beta is equal tau xy divided by r means sigma x minus sigma y divided by 2 into square plus tau xy into square root. This is sin beta. Okay, then what is our sin gamma? Sin gamma also equal to tau xy divided by sigma x minus sigma y divided by 2 into square plus tau xy into square root. But it means here the sin beta then the sin gamma both are equal. It means gamma is equal beta. Okay, gamma is equal beta. So then we can further simplify these equations. We are getting the alpha is equal. Okay, we are getting alpha is equal minus, I will put the I am writing in the beta value, minus 2 beta minus 2 theta. Okay, for the alpha we are getting the second value. Then for this one, the alpha, by making the alpha into subject, Yeah, minus 2 theta. Sorry, here it is plus, no? Sorry, this one should be plus. Okay, this one should be plus. Here what happened? By making alpha into subject, 2 theta minus beta, yeah. Okay, alpha is plus. So we are getting, sorry, this one be corrected in this way. That means from this equation we are getting alpha is equal minus 2 theta. Then next we are getting another answer for the alpha is equal minus from this equation minus 2 beta plus 2 theta. Okay, then for the alpha we are having the two values. Okay, for the alpha we are having the two values. What value we can accept? Okay, what value is correct value? Okay, if we take the alpha, here we are having the alpha as the two values. If you take alpha is equal minus 2 theta, what it means? We have to measure. You can see angle is double. In the first situation, let's take the first situation, angle is double. So actual angle is theta, then alpha should be double and should be measured in a clockwise manner, in this direction. Okay, in this direction. Okay, then if we take minus 2 beta plus 2 theta, what it means? It also representing the minus 2 beta. What is minus 2 beta? That means this kind of point, minus 2 beta point representing, then plus 2 theta. Okay, minus 2 beta, here in this direction the minus 2 beta, then plus 2 theta. Somewhere this kind of point is representing. Okay, okay, according to that we are having the two possible point. So what are the 2 points? This is the one point, the C. For this one, this is the point C. So both are representing the sigma theta value. But we can't accept this point. Let's take this is C, this is C dash. Yeah, we can accept this C dash point. Why? Here the tau theta should be positive value. Okay, according to sign convention, tau theta should be positive value. So we can accept only alpha is equal minus 2 theta. Okay. But it means we have to measure. If we take shearing stress when drawing this Mohr circle, and if we take the shearing stress as anti-clockwise direction as positive, we have to measure this alpha angle negative 2 theta. You can see angle is double and also negative, negative from reference point. The reference point mean the reference plane. Reference plane mean the plane which is normal to the x coordinate direction. Okay, from this point we have to measure anti-clockwise direction, this angle, and also it is negative. Okay, it is negative. Okay, if you take a clockwise shearing stress as positive, if we take in this direction as positive, then we are getting the answer alpha is equal 2 theta. What it means, we have to measure this angle in a positive manner, positive direction, that means anti-clockwise direction, that means same with the two-dimensional, same with the angle measuring sign convention with the planar stress problem. We have to measure it anti-clockwise, then angle is double. Okay, this is how the sign convention and the angle is double. Why the angle is double? Because this is how we are mathematically proving that one also. The proof we can do using the shearing stress also. Okay, by taking the shearing stress also we can prove this alpha is equal to theta. If we are taken the clockwise, we have to take the 2 theta. If we are taking the anti-clockwise, we have to take minus 2 theta. So I will show that one also. Sign convention explanation using the by taking the tau theta angle, tau theta shearing stress. Okay. Why you are using this sign convention? That means why we are using this sign convention? What is sign convention? If you take clockwise shearing stress as positive, you have to measure angle anti-clockwise and also angle is double. If we take anti-clockwise shearing stress as positive, we have to measure the angle in the clockwise direction in Mohr circle diagram, and angle is double. Okay. Then let's see if we take the same diagram. I'll draw that one. Okay, let's take this kind of two-dimensional planar problem. Okay, our heading is sign convention explanation in Mohr circle diagram. Okay, let's take this is sigma x, tau xy, sigma y. Let's take this is our plane stress problem. Then we are going to find the stresses on this kind of inclined plane. Let's take the inclined plane we are interested. Okay, sigma theta and tau theta, that inclination is equal to theta. Okay, theta. Okay, then we can draw this Mohr circle diagram like this. Mohr circle diagram, I am going to draw this for this one. Mohr circle diagram. Mohr circle diagram. This is sigma theta. This is tau theta. Let's assume we don't know what is the sign convention we have to use. Then let's assume we are taken anti-clockwise shearing stress as positive for this diagram. Then we can look at this A point which is normal to the plane, which is normal to the positive x coordinate direction. We are taken as A. So then let's we locate the A. The normal stress same, A sigma x somewhere in this kind of position, sigma x, then the tau xy according to our sign convention it is positive. Okay, tau xy. Okay, then this is sigma average, this is r, and this sigma average is equal sigma x plus sigma y divided by 2. Then the r is equal, what is r? Sigma x minus sigma y divided by 2 into square plus tau xy into square root. Okay, this is r. Then let's take this angle as beta. Okay, then what is the then the C point we are going to mark. C point we are going to mark with reference to, let's take this point as C. Okay. This C point we are going to mark with reference to this A point. Let's assume we don't know what is in which direction we have to take the angle. Let's take any arbitrary point, the mark on the circle. Let's take we are measuring this angle in this direction. Okay, let's assume this is any arbitrary point we are marking. This is the alpha angle. Okay, if we know the alpha, we can exactly locate the position A. Okay, position C, we can exactly locate with respect to A point. Okay, then we are going to find the alpha angle value for the alpha angle. Then we'll definitely get alpha is equal minus 2 theta, because if we take the angle in this direction, sorry, shearing stress measurement in this direction, alpha should be other way around. Angle have to measure other way around, and angle should be double. So finally we have to get alpha should equal to minus 2 theta. This is the expression we are going to obtain. Okay, this, if we can obtain this expression, that means we have to assign the sign convention according to that one. Okay, then let's take what is this one is sigma theta. What is this one? Tau theta. From the planar stress transformation equation, what is tau theta? Tau theta is equal minus sigma x minus sigma y divided by 2 sin 2 theta plus tau xy cos 2 theta. From this Mohr circle diagram, what is tau theta? From the Mohr circle diagram, this is from the planar stress transformation equation. Then the Mohr circle diagram equation, tau theta is equal what is the value? Sigma average plus sigma average, sorry, this height, no, sorry, this height r sine alpha plus beta, r sine alpha plus beta. These two should equal, because that is representing the same point. It is representing the same point. So these two should equal. These two should equal. Okay, these two should equal. That means I am going to equate this A and the B. Then we are getting this value minus sigma x minus sigma y divided by 2 into sine 2 theta should equal to, sorry, plus tau xy cos 2 theta is equal r sine alpha plus beta. Okay, the entire equation I am going to divide by the r. Entire equation I am going to divide by the r. Then minus sigma x minus sigma y divided by 2 divided by r sine 2 theta plus tau xy divided by r cos 2 theta is equal sine alpha plus beta. Okay, sine alpha plus beta. Okay, then we can further simplify this equation. For this one, so I am going to put the gamma. Let's take this kind of rectangle triangle, the gamma. If this is sigma x minus sigma y divided by 2, then this is tau xy. Cos gamma is equal to this term. Cos gamma is equal to this term. Okay, cos gamma is equal to this term. Then sin gamma is equal to this term. So then I will write this equation: cos gamma minus sin 2 theta plus, here it is sin gamma. Sin gamma is equal cos 2 theta is equal sin alpha plus beta. Okay, sin alpha plus beta. Okay, then we can add these two equations. That means here this equation sin gamma into cos 2 theta minus cos gamma into sin 2 theta is equal sin alpha plus beta. What is this equation? How to add? Sin A cos B minus cos A sin B, sin gamma minus 2 theta is equal sin alpha plus beta. Okay, in simply we can say gamma minus 2 theta is equal alpha plus beta. Okay, By making the alpha into subject, we are getting the alpha is equal gamma minus beta minus 2 theta. What is the value we are getting? This one. Okay. Then what is beta? From this equation, what is beta? Beta. From this triangle, what is beta? The sine beta. Sine beta is equal from this triangle. Sine beta is equal tau xy divided by r. No, that is equal to gamma. No, it is equal to, the angle is equal to gamma. So then the beta is equal to gamma. So then we can cut these values. The final we are getting alpha is equal minus 2 theta. Alpha is equal minus 2 theta. Okay, alpha is equal minus 2. What it means, if we take angle measurement in anti-clockwise direction, if we take, when drawing the Mohr circle diagram, if we take a shearing stress measurement in anti-clockwise direction as positive, we have to measure angle. We have to measure angle we have to measure angle in a clockwisely and angle also double, and angle also double. You have to measure angle clockwisely 2 theta, angle also double. Okay, that is the thing we got. If we take this angle measurement as a positive manner, we will definitely get this equation. That means if we draw this diagram in this way, if we draw this diagram in this way, if we take the clockwise shearing stress as positive, then we are getting the angle measurement somewhere in here, angle measurement same with the angle measured sign convention we assign for the two-dimensional stress problem here. Okay, what is sign convention when angle measurement? From the positive x coordinate direction, anti-clockwise angles are positive. Okay, if we take clockwise shearing stress positive, we are measuring angle anti-clockwise from the considering reference plane, and angle is double. Okay, in a further problems, these are the sign convention we use. We are going to use these are the sign convention we are going to use. Clockwise shearing stress we are taken as positive. Clockwise shearing stress we are taken as positive. Then remember, we have to measure angle anti-clockwisely, and angle is doubly represented on Mohr circle diagram. Okay. Then let's move to some example. Then you will more clear with this sign convention and everything. Okay. Okay. Okay, this is the problem we are going to discuss. Okay, for the plane stress system shown, determine the principal stresses and the plane, and second, stress exerted on a plane obtained by rotating the given element clockwise through 30 degree. Okay, then here the sigma x is equal 60 megapascal, sigma y is equal 15 megapascal, tau xy is equal 30 megapascal. These are the data we are given. Then we have to calculate inclined plane stresses. Then what is the inclined plane? So stress exerted on plane obtained by rotating the given element the clockwise. Sorry. So if we rotate this clockwise, that means for this kind of plane, on this kind of plane, what is the stress? If you rotate this stress element in clockwise by 30 degree, if this is 30 degree, what is the stresses? Sigma x dash, sigma x dash, sigma y dash, sigma y dash, tau x dash y dash. These are things we you have to determine. Okay, then let's move the let's see how to solve this problem. When using the Morse circle diagram method, you don't have to remember any of the equations. Okay, you don't want to remember any of the equation. We can draw easily Morse circle diagram. Okay, then in this diagram, let's take this point as A. Let's take this point as B. Okay, let's take this point as B. So according to the sign convention we obtain, these 2 points should be represented the diameter of the circle. Okay, because angle between these two is 90 degree. So if these 2 points lie on the circumference of the circle, so this angle between these two should equal 180 degree. That means this is the diameter representing. Okay, that is the thing we are using when drawing the Morse circle diagram. Okay, what is the A coordinate? What is the A coordinate? Okay, A coordinate is equal. A coordinate is equal. What is A point coordinate? 60 into 30. 60 into 30. Here, 60 into yeah. We have to follow when drawing the Morse circle diagram. I explain we have to follow certain steps. So what is the first step? Mark the plane stresses on 2-dimensional stress element. Here we mark the stresses on 2-dimensional stress element. Then draw the Morse plane. Okay, I follow these steps. Okay, draw the Morse plane. Okay, draw the Morse plane. The Morse plane. Sigma theta, tau theta. As a good practice, use this notation. Tau theta. That means we are getting clockwise shearing stress as positive. Then draw the Morse plane. Identify the two perpendicular plane stress on the stress element A and B. Okay, for the A I am taking this plane. What is A point stresses? According to sign convention we assign for the Morse circle, we have to write these values. A for the A 60, comma, here you can see tau value for this shearing stress acting on this A plane is anti-clockwise direction, but according to our sign convention it should be negative 30. Okay, negative 30. Okay, then the B point coordinate are 15, then now it is clockwise, it is tau theta is equal 30. These are the 2 perpendicular point stresses. Okay, we have to locate these 2 points on the Morse plane. Then the step 4, mark the 2 points A and B on the Morse plane. So I am going to mark these 2 points on the Morse plane. Okay, when drawing okay, I am going to mark this 2 points on the Morse plane. Let's take 60. Let's take for the 60 I am going to take the 12 centimeters here, approximately 60. Then 60, then the minus 30. Okay, minus 30. Yeah. It means this kind of point A. Okay, then for the B I am taking 15. Okay, 15 and plus 30, 15 plus 30. Okay, this is the B point. So what is this value? This value is equal to 60. In this method you don't want to remember any of the equations. Okay, you don't want to remember any of the equations. Okay, here it is minus 30, here it is plus 30, here it is 15, here it is 60. Okay, then what is the next step? Join the 2 point, no? Join the 2 point and mark the intersection point as O. So I am going to draw this 2 point. Okay, join the 2 point. Then this point is the center for the circle. Okay, then I am going to draw this circle. Just sketch. So no need to draw to a scale. If you are drawing this scale, you can directly read, but we are expecting to obtain the unknown using the considered geometry of this figure. Okay, so that just sketch. This is the are you clear now? Okay. Okay, this is the circle we got. We have to extend this one. Sigma theta. Okay, then here we construct the Mohr circle diagram very easily, no problem. We don't have any equations. Okay, then I am going to draw the Mohr circle diagram. Okay, that's okay. Then in this problem I am going to do this geometric construction. This is 90 degree. This is also 90 degree. You can see these two angles are equal, and also these two is equal. These two angles also equal. Okay, then this side also equal. That means these two angles are equal angle. Okay, these two angles are equal angle. Okay, then you don't want to remember any of the equation. So let's see how to obtain unknown. Then here you can see this is the maximum stress point where sigma is maximized. And where the sigma is minimum. Here where the sigma tau is maximized. Where the tau is maximized. Tau maximum. Here where the tau is minimum. Okay, tau is minimum. Okay, then let's see how to obtain these unknowns. Okay, let's see this how to obtain this unknown. Let's take this point as O dash. This coordinate center I'm taking as the O dash. Then let's take this point as C. Let's take this point as D. Let's take this point as E. Okay, then EC is A and D. Okay, what is CD length? Okay, what is CD length? Here it is 60, here it is 15. These two are equal. CD length is equal 45. Okay, then OC is equal, CO is equal half of this one, 22.5. OD also equal this value 22.5. Then what is O dash O? What is O dash O? If this is CO is equal 22.5, if this is 15, O dash equal 37.5. 37.5. Okay, then very easily we can obtain these values. O dash equal 37.5. Okay, what is O dash? Yeah, 37.5. Okay, then the problem is asking R. So I'm going to write the R. What is R? R according to this ODA triangle. From ODA triangle, what is R? R is equal OD square plus DA square root. Okay, what is our OD? OD is equal 22.5 into square plus DA. What is DA? 30 into square root. Then R, for the R we are getting 37.5. R we are getting 37.5. Okay, then problem is asking to find the maximum principal stress. That means the principal stresses, that means sigma maximum and sigma minimum we have to find. What is sigma maximum? Sigma maximum means O dash E, no? O dash E. O dash E is equal O dash O plus R, no? R. Okay, this is a special situation is contact this circle is passing through this coordinate center. Don't forget about it. For in generally O dash O is equal O dash O plus R. Okay, so what is O dash O? 37.5 plus what is R? Again 37.5. So what is the value for the sigma maximum? Okay, 37.5. 75. Okay, sigma maximum is equal 75. Okay, O is equal 75. Then we are going to find the sigma minimum. Okay, sigma minimum. What is sigma minimum? Sigma minimum mean this point, no? You can see that is passing through the coordinate center. Okay, that is passing through the coordinate center. So that is equal to 0. Sigma minimum is equal to 0. So that means what are the two principal stresses? Sigma maximum is equal 75 megapascal. Sigma minimum is equal 0 megapascal. Okay, 0 megapascal. Then along which plane it is maximized? Then what are the plane this stress is maximized? Okay, this plane. What is this plane? We are going to find. Okay, then we can say this plane if you know this angle, no? If you know this angle, we can directly say if this is 2 theta, we are taken half of this angle. We can see the. So let's take this angle as alpha. Using from this triangle ODA triangle. ODA triangle, from ODA triangle, tan alpha is equal AD divided by OD. What is AD? AD is equal 30. OD is equal 22.5. Then alpha, we are getting the answer for the alpha. (53.13 degree). Alpha is equal 53.3 degree. That means what is that means 2 theta is equal alpha. So theta is equal theta is equal 26.56. This is the theta angle. This is the theta angle. Okay, theta angle. At this angle, the normal stress is maximized. Normal stress is maximized. Okay. Then you can see to this maximum plane at an angle 90 degree. Here this total angle is 180. So we have to divide the half of this angle. For this, from this plane at a 90 degree, stress is minimized. Okay, stress is minimized. No need to find that one. No need to find. We can, by looking at this Mohr cycle diagram, you should be able to say at an angle 90 degree to this plane, stress is minimized. Okay, in that way we can represent this. Okay, the maximum shearing stress also I am going to find. Okay, before going to that one, I am going to represent this maximum values on a two-dimensional stress element. Okay, then let's take this is our stress element, two-dimensional 60. Here it is 30. Okay, what is the value for this one? 15. Okay, 15. Okay, then this is the positive x coordinate direction. X coordinate direction. From this x coordinate direction, we are getting alpha is equal theta is equal 26.56. At theta is equal 26.56, stress is maximized. Okay, better to draw in somewhere here. We have more space. We should have more space. Okay, I will draw this one. Then here it is 60. Here it is 15. Here it is 30. Okay, then this is x coordinate direction. Then alpha at an angle 30 degree direction, sorry, 26.56. Along this direction, stress is minimized. Okay, along this direction, stress is maximized and minimized. And this is the maximum stress direction, 75 megapascal. Here it is also 75 megapascal. Here it is 0. Here is 0. Okay, this is how we are finding the maximum stresses and principal stresses and plane which they are acting. Okay, then again we have to find the maximum shearing stress. Here the shearing stress, what is the tau maximum? Okay, what is the tau maximum? Okay. Tau maximum is equal to R. Tau maximum is equal to R. What is R value? 37.5. That means this height, no? This height is equal to R, radius of the circle, megapascal. So in this point it is clockwise, in this point it is anti-clockwise. Okay, then we can mark that one also maximum and shearing stress on a stress diagram. So what is the angle for this one? For this angle for the maximum shearing stress plane, the 2 theta angle is equal for the maximum shearing stress plane alpha plus 90. Alpha plus 90 means alpha is alpha, we got 53.13. 53.13 plus 90. 53.13 plus 90 is equal 143.13. 143.13. So then we have to take the half of this angle when representing on a two-dimensional plane stress. Theta is equal 71.565. Okay. Then here it is. What is this angle for this one? 26.56. Okay. Then you can see another important thing I am noticing you. For the maximum principal stress plane, the shearing stress plane at an angle 45 degree to the maximum shearing stress plane. So what is the value we got? 71.56556. For the maximum principal stress 26.56. Always this is true. This at an angle 45 degree to the maximum principal stress plane. Okay, we can mark that one also. We are measuring anti-clockwise shearing stress as positive for this plane 45 degree. Okay. Then we can mark shearing stresses. Then the shearing stress, clockwise shearing stress is tau max. It is acting in this direction. It is 37.5 stresses we can mark in this. Okay, stresses we can mark in this. Okay, this is how we are marking. This angle is equal 45 degree. This total angle is equal 71.56. 71.56. This total angle is equal 71.56. This is how we are finding. You can see that we don't have used any of the equation. You don't want to remember any of the equation. You can directly find the principal stresses and also the plane using the Mohr circle diagram. Okay. Okay. This problem also asking to find the stresses at an angle 30 degree. This the problem also asking to find the second part. The stress exerted on the plane obtained by rotating the clockwise. If you rotate the clockwise, that means in this situation the theta is equal. In this situation theta is equal minus 30. Minus 30. So in we are representing it on a Mohr's plane. It's a double the angle. That means minus 60 we have to represent. Okay. From the A point we have to take the angle measurement in anti-clockwise direction because it is minus 60 we have to consider. Okay. Then this is alpha. This alpha, what is alpha? We got 26. Okay. Then what is this angle? So I'm going to first mark this angle. The 90 minus 26.56. 63.44. Then the minus 60 we have to consider. So minus 60 somewhere in here. Okay, somewhere in here. Minus 60 somewhere in here. Okay, because this angle is 63 point. Alpha is equal. Here the alpha is equal 53.13. Okay, 13. So then this, what is this angle? What is this angle? 90 minus 53.13. That is equal 36. 36.87. 36.87. Okay. Then if we calculate the 60 degree from this point, this is 36 point. Again it is somewhere in here. Somewhere in this kind of point is representing. let's take this point as C. Sorry, let's take ABC. Let's take this point as X. Yeah. Okay. Then how to find that one? How to find that one? Then if you know this angle, let's take this angle as beta. Okay. Then we can easily calculate the values. So what is beta? First tell me what is beta. Here it is 36.87 because this angle is known. This angle is 90 degree. This angle is 90 degree. This is 37. So then from this point to this point 60. So this angle you can easily write 60 minus 36.87. Sorry, 60 minus 36.87, 23.13. Then this angle beta is equal, the beta is equal minus 66.87. 66.87. Okay, this beta. Okay, then we can easily find the unknowns. Okay. Then beta is equal from this triangle. Let's take this point as y. Then this O dash O minus r cos beta is equal to this stress. Sigma theta at C point is equal O dash O minus r cos beta. What is O dash O? We have found O dash O is equal 37.5 minus what is r? Again 37.5. What is cos beta? Cos, what is the beta angle? 66.87. Sigma theta is equal 37.5 into 1 minus cos 66.87. That means 22.77 megapascal. 77 megapascal. Okay, sigma theta is the value. Then same time we can find the tau theta also. Let's take this is tau theta, this is sigma theta. Tau theta we can find. Tau theta is equal r sin beta, but it is negative according to the our Mohr circle representation is r 37.5 sin beta. What is beta? 66.87. Then the tau theta is equal 37.5 into sin 66.87. It is equal 34.48 megapascal. You got. Okay. This is the stresses if we rotate the in a clockwise 30 degree. This is the value we are getting. Okay, this is the value we are getting. Okay, this is the value we are getting. Okay. Tau in the sigma. Okay, then these stresses also we can mark on a two-dimensional planar stress element. Okay, then this is our x coordinate, these values are equal: 60 degree, 60, this is 30, this is 15, okay. Then on this diagram we can represent this one at an angle 30 degree clockwise. That means it is representing this kind of orientation. Then on this orientation, let's take the stress element. It is sigma 22.77. This orientation 22.77. Then tau theta acting on this plane. It is here we are getting, sorry, this one is negative. Here it is negative. Negative means that is acting in this direction. Okay, in this direction 34.48. 34.48. Okay. So what is the stress in this direction? You can easily calculate this one, because in the last lecture I explained the sigma x plus sigma y always a constant. So for any plane, the two perpendicular addition of two perpendicular stresses are constant. That is equal to 22.77 plus sigma y dash. Okay, what is sigma x plus sigma y? Here it is 15 plus 60, 75. 75 is equal 22.77 plus sigma y dash. Sigma y dash is equal 75 minus 22.77. It is equal 52.23 megapascal. It means 52.23 megapascal. Okay, this is how we are finding the stresses using Mohr circle diagram. I think you all clear with this example, no? Yeah. Then let's move to the example. Okay. Okay. Then next example, the example 2. For the plane stress shown, determine the principal stresses and planes. Okay, principal stresses and planes. Then you can see the sigma x is equal 100. Then sigma y is equal 60. Tau xy is equal for this according to sign convention, the minus 48. Okay, minus 48. Okay, then let's see the Mohr circle diagram for this stressors. Let's draw the Mohr plane. Let's draw the Mohr plane. Okay, Mohr plane. Then we have taken the clockwise shearing stress as positive. This is sigma theta. Okay. Then we have to identify the two coordinate point A and the B. What are A? This the coordinate of A. The coordinate of A according to our Mohr plane sign convention. This is 100. This is clockwise. It is positive. Okay. Remember this one. This is according to this sign convention when marking the stress element is negative, but according to the Mohr plane, the Mohr circle diagram, it is positive. Okay. So what is the B coordinate? What is the B coordinate? What is the B coordinate? B coordinate is equal 60 positive. Then here it is negative because it is anti-clockwise. It is anti-clockwise, minus 48. Okay. Then we can locate these 2 points. the Mohr plane. The A is equal 100. A is equal 100. I'm going to take 100 and here 100 and the 60, 160. Okay, then this is 100, this is 60. Then for the A point, the 48, the plus 48. This is the A point. Okay, this is the point A. Okay, then we can locate the point B. This minus 48 from the 60. Minus 48 somewhere here. B. Okay. Then what is the next step? Join the two A and B. Okay, then mark the point O. Okay, then mark the point O. Take the radius OA, then draw the circle. Okay, you can directly sketch, no need to use the compass to draw the circle. This is sketch. Okay. Then draw the circle. Okay, this is the one we got. Okay, then I will do this geometric construction for this one. Okay, then I will do this geometric construction. This is 90 degree. Then you can see these two triangles are equal triangles. This is 90 degree. These angles are equal. This one also equal. So these are equal triangles. Okay, equal triangles. So then let's take this is point as O dash. A and B. A B. Let's take this C. Let's take C E E. Let's take this point as F. Okay. Then what is the maximum principal stress? Where's the maximum principal stress point? This is the maximum sigma maximum point. This is the sigma minimum point. Then where's the tau maximum point? As the tau is maximized, this is the tau maximum. This is the tau minimum. Okay, tau maximum. Okay, tau maximum. Okay, here we have successfully complete the drawing of the Mohr circle diagram. Okay, then we are going to find the maximum value. Okay, then maximum value. So first tell me O dash D. O dash D is equal 100. Okay, then the O dash C is equal 60. Okay, then CD is equal, what is the value? CD is equal 40. CD is equal 40 from this diagram. Okay, from this diagram CD is equal 40. Then what is CO? CO is equal half of this value, equal 20. Okay, if this is 20, what is O dash C? what is O dash C? O dash C is equal, O dash C is equal, sorry, O dash CO, CO is equal 20, CO is equal 20. Then O dash C is equal, the O dash C, heat is 60. Okay, heat is 60. Then what is O dash F? O dash F, how to find the O dash F? Okay, O dash F is equal, O dash F is equal O dash O minus R. What is O dash O? O dash O is equal 60 plus this value 20. 60 plus, that means O dash C plus CO minus R. Okay, then that means considering the geometry of this figure, we can easily write these values. Okay, consider the geometry of this figure. Then what is surface? We are going to find the R. What is R? R is equal, here it is dA into square plus OD square root. Okay, considering OD a triangle, from ODA right angle triangle, then we can write this one. Okay, then okay, then R is equal, what is dA? dA is equal this height for A 48 square plus OD this OD is equal 20, CO is equal OD is equal 20 into square root. So I'm going to first find this value. It means R is equal 52. R is equal 52. So then we can find the O dash F. O dash F is equal O dash C. O dash C 60 plus 20 plus 52. O dash F is equal 28. But it means O dash F length, that means this point is representing the minimum stress. So we can directly say sigma minimum is equal 28 megapascal. Okay, 28 megapascal. Then what is the O dash E length? O dash E length. How to find the O dash E length? O dash E length is equal O dash O plus R. No? O dash O plus R. What is O dash O? O dash O. O dash, sorry, O dash, yeah, O dash O is equal, O dash O is equal O dash C plus CO plus R. Okay, then O dash E is equal, O dash E is equal O dash C. What is O dash C? It is 60 plus CO is 20. Okay, plus R. What is R? We got 52. Then this answer is equal 80 plus 52, 132. 132. That means sigma maximum value is equal 132 megapascal. 132 megapascal. Very easily we can calculate these maximum principal stress and the minimum principal stress. Okay. Then how to find the angle? How to find the angle? What is this angle? Let's take this angle as beta. What is this angle? Tan beta is equal, using this triangle, 48 divided by its length 20. Then that means that will give the answer for the beta. Beta is equal beta is equal 67.38 degree. Okay, beta. Then from the A point, the clockwise direction 67.38. What is the actual angle? The actual angle, that means minus actual angle is half of this value. Then the angle is measured in a clockwise direction, that means negative angle 67.38 divided by 2. That means theta is equal minus 33.69. The sigma is maximized. This is the maximum stress plane. Okay. Then at an angle 90 degree, we can directly say sigma is minimum. Okay, problem. And then this I'm going to locate this stress values on a I'm going to locate on a two-dimensional stress diagram for these stresses. Okay. Let's take the coordinate, the 100, 48, 60, okay. Then from the positive x coordinate direction, this is the considering reference point A plane. Then from this A plane, you have to measure angle minus 33.69. Okay. So then minus 33 point, somewhere in this kind of direction. Stress is maximized along this direction. 132 megapascal in this direction, 132 megapascal. Then at a 90 degree, it is minimum. That what is the minimum value? Yeah, it is 28 megapascal. 28 megapascal. Then the shearing stress acting on these two planes are equal to 0. There is no shearing stresses. Okay. Then the tau maximum. What is tau maximum? Is equal to R. What is the tau maximum? Yeah, this is the tau maximum value. Tau maximum value is equal to, yes, R is equal 52. No, R is equal 52 megapascal. In which direction it is maximized? From the A point. What is this angle? Let's take this alpha angle. Alpha angle is equal anti-clockwise 90 minus this beta we got 67.38. that angle is equal to 22.62 divided by 2. This alpha angle we got the 22.62. then the theta angle is equal half of this angle, 11.31 degree. Okay. Then in the same diagram we can represent the tau maximum point also, somewhere in this kind of 11 point small angle. On this kind of direction, the shearing stress is maximized. Okay. we can mark the maximum shear stress in this way. The angle is 11.13. That means with the maximum principal stress plane, this angle always the 45 degree. 45 degree. You can see here it is 33.69. Here it is 11.31. So addition of these two angles is equal to 45 degree. So always the maximum shear stress plane at an angle 45 degree to the maximum shear stress plane and the principal stress plane. So then tau maximum is equal, r is equal 52. It is positive. Positive means the clockwise direction. For our most plane sign convention is 52. Then on this plane, this is how we are marking shearing stress, maximum shearing stress and the minimum shearing stress on a two-dimensional plane stress system. Okay, I think you all more clear with these two examples. So in this lecture I explain theory of the how we obtain mathematically this equation of this Mohr's circle, and I explained the sign convention, why we are using the clockwise notation, and also why the angle is double in Mohr's circle representation using mathematically I explained. Then we discussed these two problems. I think you all more clear with these two problems. Okay, so then okay, let's continue next day class. Enough for today. Okay, thank you.